Thank you very much. It's a pleasure to be here, and it's an honor to represent Testcontainers at the Nodes 2023. Neo4j is one of my very, very favorite database projects from my early career, so I'm very happy to be here. Let's talk about integration tests. Tests are absolutely essential. We know that. Any software development process questions could be answered with tests, and they are tremendously impactful on your developer productivity. If you have good tests, you can improve your feedback loops. You can get the understanding about the quality of your code faster and easier. You can maintain your flow state, because whenever you are out of it, out of the zone, and you come back in and you need to understand what were you doing, you can just run your tests, see what fails, have the one test failing to wait for you over the weekend, and then you come back and you quickly run it and you know what you need to do next. And it also helps you with cognitive load, because tests are the best documentation about what the system is actually supposed to do, but also how different components of the system interact. So those three are currently considered being the staples, or sort of the most important axis of developer productivity. And tests have like very big impact on all of them. My name is Oleg. I work for the company called Atomic Jar. It's a startup created by the maintainers of the Testcontainers libraries. And we try to make experience developing applications better. We want to help the developers. We want to make them more productive. We are building tools and libraries for creating easier integration tests, setting up environments for your applications easier. And in that capacity, I'm very, very happy to talk to you right now. There are a number of products that Atomic Jar maintains. There are Testcontainers libraries, open source libraries in different languages. We're going to talk about them now. There is a desktop application which is free. You can just download and use it. That simplifies some use cases for working with Testcontainers libraries. And if you use Testcontainers, I would encourage you to check it out. And then there is also a cloud backend that are completely optional. If you don't want to deal with your own Docker installation, this is what you can use. You can find me online. If you don't have a chance to get questions here, just ping me. I'll be happy to answer and talk to you. All right, back to the tests. Why do we want to specifically talk about integration tests? In the past, we sort of collectively had an understanding about how our tests should look like, the test suites, what type of tests we want to run. There would be unit tests that would cover everything with small independent units of tests that will maybe test a single function or a single method. And then on top of them, there will be integration tests, and on top of them will be end-to-end tests, which would be slow. And the higher up this pyramid you go, tests will be slower and kind of more annoying to maintain, and in general, less pleasant. So in the modern understanding how we develop software, specifically after the migration to microservices, more and more teams put more emphasis on having very good integration test suites, because the behavior of the system very often is encoded in how your services interact with the rest of the system. And that is much better to test using the higher level integration test, a functional test, if you will, that will run with the actual real technologies that you can use in production, which will not rely on the mock, which will not modify the code path of your own application under test, and which will, with a higher chance, reveal problems if your application has them. And there are places where you need the implementation detail tests for the heavy business logic operations, when you're writing libraries or when you're writing a compiler that does a transformation internally with the data. And there are places for the integrated tests which run in environments similar to production, but the bulk of your tests, it could be integration tests. And you could make informed decisions about the quality of your software automatically based on the results of the integration tests. And this is what gives us the developer productivity boost. Because if our control checks are automatic and we trust them, meaning when they're green, we know they're good and we can deploy to production. And when they're actually failing, we know they're failing for a reason and not because, well, it's Tuesday and one particular test always fails on Tuesday. We can develop much faster with safety, and we know where we're going with our projects. And over the years, integration tests transformed how we run them. We did that extensively in the past, and then very often integration tests would mock some of the components of our code. And that was, of course, not great because say you have a database example, Neo4j is a database. Mocking that database integrations doesn't give you actually any confidence in the application code. You don't check the queries, you don't check the results, you don't check the mappings. It's all superficial. So mocking wasn't great. And then we started using the local setups where we would install things locally. And that would be error prone and not scale to the larger teams. So we would virtualize the whole environment with projects like Vagrant, or people used Ansible for development as well. And that was not great because our tools, we want our tools to be local, my ID, my application. So there is a quick turnaround. So I don't want that. Then Docker came to the picture and transformed everything because it allowed you to virtualize just the parts of the ecosystem that you want. And then Docker Compose made it easier to create larger environments that will have different services interact together. And now, but the most flexible example is how we can use it is, of course, using the Docker API. And this is what Testcontainers libraries are doing under the hood, because programmatically you can create those environments with much higher precision. You can definitely precisely create the minimal environments that you need for the particular test slices, and you can have the isolation levels that you want for your individual tests. This allows us to get the ultimate environment parity, which is one of the important factors in the 12-factor apps. And very often they talk about developer and production parity. I think personally, it's very important to recognize that we have CI as the another environment that is the source of truth for the application, what quality the application is. And having this programmatic access to creating environments on the fly makes development and CI absolutely identical, and then helps you with having the same setup as in prod. So how do we achieve this? Well, enter Testcontainers. Testcontainers are open source libraries, and they give you this API to programmatically create, manage, configure, and use services in Docker containers. It requires a compatible Docker environment, but after that, it can run anything that runs in a Docker container from your source code itself, which naturally makes it so good to be put into the test to create environments for the tests themselves. It works for any language. Well, there are currently around 10 popular libraries that Testcontainers is implemented in. The Java version is the most mature, and my personal experience comes from Java, so I'll be showing you Java examples today. But there are a very popular Go version, which cloud native projects and various open telemetry projects use extensively. There is the .NET version that is currently the fastest growing, relatively speaking, Testcontainers implementation that we have. And there are also important ones for languages like Python and the node.js implementation for your JavaScript and TypeScript applications. They encode the same basic concepts, they encode the same basic API names, and allow you to do similar things. The implementations are a little bit different. They're not derived from each other. They are idiomatic. So, well, Node.js one is async await first, and the Go one does things the way the Go developers would expect the library to do, and so on. So you can use the libraries, and you can issue calls to your containers to do anything you want. And then one of my favorite features is that it works across your whole ecosystem of technologies that you need to do. There is a predefined modules, the ecosystem of modules, where test containers implementation for the technology of your choice is already provided to you out of the box by the community, by the Atomic Jar team, or even by the collaboration between Atomic Jar team and the vendor. I think this is the case with Neo4j as well. So if we look at the test containers com modules, and you go and you say, for example, Neo4j is an official module, which means that it's not the implementation of it. It's not just created by the community. It's not just encoding sort of the abstractions and the requirements and best practices for integration tests that Atomic Jar teams know about, but it also was created in collaboration with the Neo4j engineers. So it also uses Neo4j idiomatically, and you can be certain that it gives you the good quality setup out of the box. So it works for the stack. And then, well, the next slide is just demo. Let's go and see how it looks and how it feels. Here, my sample project. It's a small Java project, is in my IDE. It has a little data model that is Neo4j aware. So it's not a thin model. It knows how to update itself in an active record fashion. But we're gonna just use this for interacting with the Neo4j database. How it is to get started? We add the test containers dependencies to other projects. We get the core, and we also would like to get the Neo4j test containers module, which will give us the abstractions that are easier to use. And then in my test, well, API is not test specific, but we want to run something. We want to run something ourselves. So what we can do, we can say generic container, and this is the basic abstraction that encodes any container that we want to run with test containers. And we can say Neo4j, and we can say new generic container, and we pass the Neo4j Docker name, 413. Was it 5? It was 513. Sorry, 513.0. Right. This is what we have now. And now this abstraction, this Neo4j object has the lifecycle message, so we can start it and we can stop it if we need to do. It doesn't. The object creation itself does not create the container, and then but it gives us the lifecycle methods, and it gives us the convenience methods for what we can configure the objects into, right? So we can provide the configuration for the container, and we can do anything that the Docker container needs to do for us. So we can create the environment variables if we want to. We can specify a pilot. We can specify anything else that we want. We can overwrite command if we want to run a sample, a different thing. We can copy files to containers. We can follow the logs if we want to. We can specify very cool things like Neo4j with waiting strategy, waiting strategy, which means we will wait for a certain condition that makes our service in the container start. Right. Well, let me just say assertions through Neo4j is running. I think this is a decent test now, and I can maybe run this test. I'm not actually sure, because I don't know if I can run my Neo4j container like this. should I even run my Neo4j container like this? You can, and you can put in the containers anything you want, but this is not the idiomatic way of doing this, because a better way of doing this would be to say that I want my, well, let's remove this. I don't think this actually works. My Neo4j, I want it to be a new Neo4j container. The abstractions that is provided from the library and encodes exactly what ports I need to expose for my container to run properly, what are the configuration methods and commands that I need to run to configure it properly, what is my convenience methods to get the connection strings to the methods, and so on. So this is a much better version, and this comes from the library which we added, which is the Neo4j module for test containers, right? So we do the same thing. We're gonna say Neo4j 5.13.0, and we don't need to do more. We're gonna start it, and we need to assert something. We can create the driver of that, right? After this, we can say Neo4j get bulk URL. So this is how we connect our application to the thing, and we can turn that into driver very easily. So we can, for example, say, well, driver, give us a driver, and if we new movie repository from the driver, and well, we can create the matrix, right? And this is our movie, the matrix. Very good. And we can assert, for example, that our assert that the matrix. Well, we can assert that ID is not null, because the ID is provided in the movies. The ID is not in the title. We don't create the ID here, right? So, and then we can do Neo4j stop. Can we run this test? Yes, we can. Let's see what happens. Let's see what happens. My test is running. My test containers connects to the Docker environment that is configured, and then it runs. It starts my Neo4j image. It will download it if you don't have it locally, and it needs to pull it, and then it test runs. Did it actually run? Let's see. I'm using Testcontainers desktop as my application, so I can do little things that are a little bit sometimes awkward to do in the code. So I will freeze the container shutdown and run my test again, so that my Neo4j instance will not actually go away after the test. Testcontainers takes extra care to do the cleanup for our environments, because we want them to be repeatable, so we can run it again and again and again. But it also means that the containers are being removed and stopped automatically. Even if we wouldn't call Neo4j stop here, it will be removed. Even if my Docker daemon would run on a remote machine, it would also clean up the containers afterwards. But I run this, and then I can also access my Neo4j instance very easily. Testcontainers desktop offers me services. If I look at my Docker PS, right? If I look at my Docker PS, my Neo4j runs, and it maps my ports that I want to access to high-value ports, which is a great integration testing practice, because I can run things in parallel, and there will be no conflicts. But now, to access this locally, I need to change this configuration, or I can use the desktop application where I can configure my files and say anything that runs with test containers that's Neo4j, please use stable local URLs to get into those. So if I go to my browser, and if I go to my URL there, the stable URL, I can connect using the stable bolt connection. I and connects using my stable bolt connection out of the box. And then after the fact, I can, please don't save the passwords. After the fact, I can, for example, run my commands, right? So I can match movie and then, well, return movie. If I run this, we'll get our matrix. We get the matrix, right? So this is how you can use test containers and work with the tools locally. If I unfreeze the containers, my tests will finish and my containers will go away automatically, as I said. So if we look here, we do Docker PS. There are other containers running, but there is no Neo4j. There's just Kafka images that we're going to use in the next demo. I have a couple of minutes, so I want to show another thing, how this would look in the actual proper database. Here we did three things. We configured our containers, we used the lifecycle methods, and we also configured our test, well, which is simplistic, to use this Neo4j instance. This is what you need to do with all your applications to run the test, but you don't have to do this explicitly like this in your test all the time. So this is how we're going to do it. If I look at a typical, for example, Spring application project, this is my Spring application. It does deal with product values that are just, well, some products that have some data. It will this actually will use Neo4j not as a graph database, but as just a data store. But this session is not about the intricacies of the databases, but about how to test against that. So this is how we do it. We import the test containers libraries. This is a Spring application, and Spring provides a great integration both with Neo4j and with test containers. So we can do exactly that. So we add the starters to Neo4j, we add the starter to test containers, and then we can start testing. In our tests, what I can do, I can obviously create the test. We need to do three things. Remember, we need to create the container and configure that. We needed to manage the lifecycle, and we needed to inform our tests where our Neo4j is running. We do it in the following manner. So we create the containers the same way because we do have the abstractions. If we want to configure it further, we can, for example, provide the Neo4j config, or we can copy particular files to the container to act as a sort of the entry point into this. So this is our configuration part here. We just configure it using fields or any sort of abstraction if you want to keep like a single instance of Neo4j container per Spring context or per Spring, just the whole JVM process. Now, the lifecycle here is managed with those little annotations. They come from the JUnit Jupyter extension, from Testcontainers JUnit Jupyter extension, and they will tie the lifecycle of the containers to the lifecycle of your tests. We annotate the class with test containers. We annotate the fields with the container annotation, and that gives us the lifecycle. If the field is static, it will act the same way as if you put the start and stop calls into before all and after all methods in this class. So it will start one instance per class, and if the instance is instance, it will start one for every test method. You can also use it with the sort of the default test instance annotations from JUnit, and then just put the fields in there and manage the lifecycle yourself. But with the annotations, you can just completely tie it to the lifecycle of tests, and they will get a very good level of isolation, because every test class can, for example, with the static field, will get a separate environment that you can mess up as much as you want in the code. Now, and then the connection to this Neo4j instance is managed by the service connection annotation in Spring Boot. It's a recent feature from May this year, and what it gives us, it tells Spring Boot to use this Neo4j container as the Neo4j database for the run. So if there are some application properties that define it, or if there are no application properties that define the connection to your instance, and it will work with other databases as well, or with other services like Kafka, you just add the service connection annotation on top of it, and Spring Boot will connect automatically. And then we just can run our tests. So if I run this test, what will happen? It will do exactly the same. It will create my test containers context. It will find the Docker environment. It will run the check that it can run the commands that it needs for my Docker. So we will check whether we can run the images, whether we can access HD, whether we can create the networks. It will take less than a second. So it's a one-time thing that you can, well, you can actually disable that, but it's a good thing to have it. We will run it, and then we will pull the images, start your Spring application, configure it, run it, and our tests will pass. And now what else you can do, because we have wanted, like, this is not just how to run the tests, right? You can also use the same API. Remember I said that there is nothing test specific in the API. So what you can do, you can also use it to create the entry points into your application to run it locally without actually running the tests. So some frameworks create the opportunity for this manually for you or automatically for you. For Spring Boot, you do need to do a little bit of minimal work for this, but it gives you maybe a greater flexibility. You create an entry point in your application under your test class path. You get access to the test containers libraries and the configuration for the containers. You run your application from the main class path, but you also say, please run it with the special configuration. And the special configuration can create the particular beans for your containers. So Spring Boot knows about the test containers abstractions. So if the bean is a test containers container, it will handle lifecycle for it within the lifecycle of the Spring context. We use service connection to connect to it, and this application actually uses more things. So I'm having more containers run there. So if we do this, if we run our test application, it is not the test, but it is my actual application that will start, and it will be actually running. So if I go back to my Bolt URL, and I will reconnect, and then where's well, our application start. Let's figure it out first. Can we use this application? Yes, we can. If we go to the controller, if we go to the generated images, we can, for example, run the requests. It will create me products. And then in my console, I can p product. I'm not connected. This is the only thing that I didn't figure out. It's supposed to be working. Please. Okay. You'll have to trust me that it runs. You'll have to trust me that it runs and that it works. Well, unfortunate, right? What I want to say as the final words. Test containers gives you a very flexible lifecycle API to manage your isolation versus convenience and performance concerns. It is capable of abstractions, so use the modules very well. It gives you flexibility to create any complex network topologies, and it follows the predefined best practices for integration tests, allowing parallelization, for example. All in all, it gives you this feeling that your tests are like unit tests because you work with them on your IDE, You don't change anything. You just run your application. You can debug your application, but they give you the reliable signal as if they were good integration tests. I use Testcontainers desktop. If you are getting started with Testcontainers, this is probably one of the easiest way to start with your Testcontainer setups locally. Please check it out. We'd be happy to hear all and any feedback about it. It's a new thing. So, and if you want to continue your learning about Testcontainers, testcontainers.com is the website where you can find the guides, the documentation, and some other information about that. And also join the Slack. There are a number of community members, and they can give you very good advice. And they probably have seen the setups that you have in the past. So that is a good source of sort of using Neo4j and Testcontainers in Anger in real life that you can use. Thank you very much.